Does the study need to have a hypothesis? My answer to this question is not all studies have hypotheses. So listen carefully in this lesson video and find out if you need a hypothesis in your study. A hypothesis is a tentative answer to a research question that is stated in advance so that it can be tested. It is a testable prediction about what the researcher expects to happen in his study. This means a hypothesis is the stepping stone to a soon-to-be-proven theory. Since we mentioned in the definition that hypothesis is a prediction or an intelligent guess, it means to say that it does not have to be correct. While the hypothesis predicts what the researchers expect to see, the goal of the research is to determine whether this guess is right or wrong. When conducting an experiment, researchers might explore a number of factors to determine which ones might contribute to the ultimate outcome. Elements of a good hypothesis. When trying to come up with a good hypothesis for your own research or experiments, ask yourself the following questions. Is your hypothesis based on your research on a topic? Can your hypothesis be tested? Does your hypothesis include independent and dependent variables? Remember, a good hypothesis is short and comprises clear and simple language. These are the common forms of hypothesis: simple and complex hypothesis, null and alternative hypothesis, directional and non-directional hypothesis, and research hypothesis. A simple hypothesis is a prediction of the relationship between two variables, the independent and the dependent variables. Example: study anxiety among senior high school students is related to their academic performance. A complex hypothesis examines the relationship between two or more independent variables and two or more dependent variables. Example: the profile, classroom leadership, and management skills of teachers affect the level of students' academic performance. A null hypothesis, denoted by H sub O, states that there is no relationship between the two variables being studied. In short, in this type of hypothesis, the researcher believes that one variable does not affect the other. It states results are due to chance and are not significant in terms of supporting the idea being investigated. Example: there is no significant relationship between the socioeconomic status and level of academic performance of students. The alternative hypothesis states that there is a relationship between the two variables being studied, meaning that one variable has an effect on the other variable. It states that the results are not due to chance and that they are significant in terms of supporting the theory being investigated. Example: there is a significant relationship between the socioeconomic status and level of academic performance of students. Directional refers to a one-tailed directional hypothesis. A directional hypothesis specifies not only the existence but also the expected direction of the relationship between the independent and the dependent variables. Example: the number of hours spent in studying positively affect the student's test results in the summative test. The term positively in the hypothesis statement implies that as the number of hours spent in studying increases, the test result also increases. Or it can be interpreted as the number of hours decreases, the test result also decreases. However, if we will change the positively affect to negatively affect in the hypothesis statement, it means to say that the relationship is inverse. It means as one variable increases, the other one decreases, or vice versa. Non-directional refers to a two-tailed, non-directional hypothesis. It predicts that the independent variable will have an effect on the dependent variable, but the direction of the effect is not specified. Example: there will be a difference in how many numbers of sources are used by students in writing their related literature. Finally, the research hypothesis. Research hypothesis states the actual expected relationships between variables. It is always expressed affirmatively. That is why it is usually called scientific hypothesis. These are some important things to consider when writing a hypothesis. First, state the problem that you are trying to solve. Make sure that the hypothesis clearly defines the topic and the focus of the experiment. Second, try to write the hypothesis as an if-then statement. If a specific action is taken, then a certain outcome is expected. Third, define the variables. In scientific experiments, a hypothesis proposes and examines the relationship between an independent variable and a dependent variable. The effect on the dependent variable depends on or is determined by what happens when you change the independent variable. Before I end this lesson video, always remember that it is appropriate to use a hypothesis when you are testing a theory. Research, which seeks to develop knowledge through understanding meaning, does not usually proceed with hypotheses. That's all for today. See you next time.